Okay, so we've got this function here, and we want to see what we can figure out about what the graph of this function looks like when we use our calculus to do that. We want to determine where it's increasing, where it's decreasing, concavity. We want to look at extrema, that sort of thing. Now, when you're going to analyze a function like this, don't forget the basics, what you learned earlier. In other words, finding domains. Because you notice here you've got a square root. And that tells you, that's one of the things that you look for to indicate that you might need to be aware of what the domain is for this function. In other words, I need to make sure when I'm working with this function that 1 minus x squared is always greater than or equal to 0. Because I don't want to try to take the square root of a negative number. Now, if you look at this, we don't have to work too hard to realize that that means that x can't be bigger than 1, and it can't be less than negative 1, right? Because if x is bigger than 1, for example, 2, you've got 1 minus 4. Well, that's a negative number. So in other words, our domain for this function is going to be, well, you could have negative 1 to 1, right? That's it. Any x value that you deal with, that you want to use, that you want to plug into this function is going to be fine as long as it's between negative 1 and 1. If you plug in a negative 1, you get 0. That's cool. If you plug in a 1, you get 0. If you plug in a 1/2, you get a positive number. But if you plug in a 2 or a negative 2, something like that, that's not in the domain of this function. So what we know about this function before we open a can of calculus on it is we know that all that happens between negative 1 and 1. So we want to figure out, well, what is going on with this function between negative 1 and 1? So we start from that, with that bit of knowledge. Now, I'm going to go ahead and differentiate it. So here I go. I'm going to find the first derivative and explore where the function is increasing, decreasing, and see what we can find out. So I've got the derivative of the first times the second. So this is going to be 1 minus x squared to the 1/2. Okay, so that's the derivative of x, which is 1 times 1 minus x squared to the 1/2, plus the derivative of the square root there. So I've got the derivative of the first times the second, plus the derivative of the second times the first. Here's the first, so here's the second. I've got 1/2, 1 minus x squared to the negative 1/2 times negative 2x. Okay, using the chain rule, right? I differentiate the outside times the derivative of the inside. There's what we have. Okay. Now, there's my derivative, and now I want to try to simplify it because remember, I want to set this equal to 0, and then I want to differentiate it again in a minute, and I don't want this mess. So what I'm going to do is, first of all, I notice I can divide out those 2's. And then I do this old trick where I'm going to multiply the top and the bottom by 1 minus x squared to the 1/2. Because when I do that here, I'm just going to get 1 minus x squared, because 1/2 plus 1/2 would be 1, so I've got 1 minus x squared to the first power. That's just that. But then when I multiply this by 1 minus x squared to the 1/2, I just get 1 minus x squared to the 0 power. So that's just 1. So what I have now from this whole mess right here is negative x squared. And down here, I have 1 minus x squared to the 1/2. Okay? So now this is starting to look a little more manageable. So what I have now, I have 1 minus 2x squared over 1 minus x squared to the 1/2. Yeah, there we go. Now, I want to start thinking about you know, finding out where this function is increasing, where it's decreasing, and where it has extrema. So what I need to do is find the critical numbers. So here I go. I'm going to look at this. I'm going to take 1 minus 2x squared equals 0. And from there, I get x equals plus or minus 1 over the square root of 2 if I solve this. So there's a couple of critical numbers in there. Now also I notice that when x is 1 or negative 1, I get 0 on the bottom. So I'm going to think about negative 1 and 1. I'm just going to look at that real quick here. I'm just going to say plus or minus 1. And let's see what we can determine from that. Because, you know, when we're finding critical numbers, we're concerned about where the derivative is undefined and where it's equal to 0. So let's see what we have here now. We have a number line here, and I've got negative 1 over the square root of 2, and I've got 1 over the square root of 2. Now, we've got this negative 1 and positive 1, but think about it. Remember, we said that this function starts at negative 1, and it ends at positive 1. Right? It begins at negative 1, and it ends at positive 1. So, I'm not going to think about anything to the left of negative 1. I'm just going to put a negative 1 here and a positive 1 over here. So really, I have these three regions. I have everything between negative 1 and negative square root of 1 over 2. I'll call that region A. I've got everything between negative 1 over the square root of 2 and positive 1 over the square root of 2. I'll call that region B. And then over here, I'll call this region C. Whoops, sorry about that. Okay, so now let's see what happens here. I'm going to pick a test value in each of these regions. In this region B, I'll pick 0. That's the easy one. Now, negative 1 over the square root of 2 is about negative 0.7. So why don't I just pick negative 0.8 here? And I pick 0.8 over here. I just want to find out, well, what's the function doing in these regions? So I go back and I take my derivative, and I'm going to do some test values here. Okay. Now remember, the derivative is 1 minus 2x squared over 1 minus x squared to the 1/2. Okay, like that. So I'm going to plug in these values. I'll plug in the negative 0.8. Now if I plug in the negative 0.8, what I'm going to get, if you plug it in this thing right here, you're going to get a negative, right? If you plug in a negative. The bottom is always positive, but up here you're going to get a negative. And you can do the computations there. But now if I put, so I get a negative here. Now if I plug in the 0 into this thing, I just get a 1. So that's definitely positive. Okay. And then if I plug in the 0.8, it's the same story of region A. It's a negative, so it's negative right here. Okay, so let's take a moment and dig what we've got. What we found out with this function is that this function is decreasing from negative 1 to negative 1 over the square root of 2. That's where it's decreasing. And over here, 1 over the square root of 2 and 1. So this function is decreasing here and here. So that's what I put. Now it's increasing from negative 1 over the square root of 2 to 1 over the square root of 2. That's where the function is increasing, on that interval. Okay. Now, remember, so here's where we apply the first derivative test. Remember, the first derivative test says if you go from decreasing to increasing, you've got yourself a minimum at that point. So we know that a minimum occurs right here at negative 1 over the square root of 2. And we know that since we go from increasing to decreasing, a maximum occurs right here. So if you go back and look at this function over here, you're thinking, okay, a minimum occurs here and a maximum occurs over here. That's what it's looking like going on. Now, you also know this, that when x is 0, just think about this, when x is 0, the whole function is 0. So right away, you can start to think, oh, well, I know what this function looks like. It looks like this. That's what I'm thinking will be the final outcome, okay, just from the first derivative. Okay, now, what we want to do then is notice that if you look at this, the graph that we put right here, you can kind of see that you have concave up here. You can just look at it. This is what we're speculating the graph looks like. Concave down up here. And if you had to guess, you would say, I bet 0 is a point of inflection. I bet that's where we have a point of inflection. Well, let's find out. So the way we investigate concavity is we take the second derivative. So I'm going to take my first derivative and differentiate it. So here I go. The derivative of the top is, well, it's going to be negative 4x. See, that's the derivative of the top, negative 4x times the bottom. Whoops, better make it where you can see it. Okay, derivative of the top times the bottom minus the derivative of the bottom, which is going to be 1/2 1 minus x squared to the negative 1/2 times negative 2x times the top. I'm running out of room. All over the bottom squared. Yeah. Okay. So everybody, okay, so any questions? Okay, so all I did was take the derivative. Derivative of the top times the bottom minus the derivative of the bottom times the top. And now I do my old trick where I just, well, first of all, I notice that this will cancel. This will divide out. Now I'm going to multiply the top and the bottom by the square root of 1 minus x squared. And let's see what we finally get here. We're going to get 4x times 1 minus x squared. That's what happens to this first term. And that's negative, by the way, negative. Now over here, I've got a negative and a negative. So that's going to be a positive. Let's see what we get. We get x times 1 minus x, 2x squared, all over the bottom, which I multiplied by the square root. So now I'm going to have 1 minus x squared to the 3/2. Okay, so there's what we've got. Now, hopefully I didn't mess up here in any way, but it looks pretty good. I've got x. Yeah, it looks all right. Okay, now let's see what I've got. Now, if I simplify this, I've got 4x here, or negative 4x, plus 4x squared plus x minus 2x cubed all over, this thing down here. Okay, now, if we were to set this equal to 0, right here, you can see that x equals 0 would definitely be one of the solutions. Because look, there's no non-zero term up here. we've got negative 5x, and well, we've got negative 3x, and then we've got plus 2x squared. So you can see right away that x equals 0 is one of your solutions. And we could explore this a little further, and we would find that to the left of it, we have concave up. To the right of it, we have concave down. But that takes you to, to the, I think that there's no need to go through this last part. I think you can pick it up from there.